Hello viewers, welcome to this session. Here in this video we'll discuss about the algebra of sets or laws of sets. First law is idempotent law. In the number system you know 1 plus 1 not equal to 1. 1 plus 1 is equals to 2. But 1 into 1 is equals to 1. But 2 into 2 not equal to 2. But in case of sets, if we operate A with A, that is A union A is always A. Suppose A is equals to 1, 2. So A union of A means there are two sets A and your union means collection of the elements either from A or from B, that is it becomes again 1, 2. So this is equals to A. And if you do the intersection, that is also, if you do intersection, that is the elements which contain in both, again we are getting 1 and 2, which is equals to A. So these two laws are called idempotent laws. Commutative law. We know 2 plus 3 is equals to 5, and that can be written as 3 plus 2. 2 into 3 is equals to 6, and 3 into 2 also 6. So here we can exchange 2 and 3, the value is same, or to do the product of this, value is same. And this has happened to the sets also, that is A union B is equals to B union A, where A and B are two sets. A intersection B is equals to B intersection A. Let A contains AB and B contains X and A. So what is the union? A union B is equals to A, B and X. And if you do the B union A, so we are getting X, A, B, and they are same. A intersection B, which is intersection means the common element, and that common element is A. And B intersection A is also A, since they are equal. So A union B is equals to B union A, and A intersection B is equals to B intersection A. Law is associative law. Here we are taking three sets A, B, C. So first, if you take A union with B union C, so B union C is this one. This is our set B. This is set A, and this is set E, and this is the universal set. And then if you do we operated B with C. Now if we do A, So this whole thing is covered. I will do A union B first. Then we union with C. We observe that A union B union C whole is equals to A union B whole union C. Similarly, for intersection, the common element B intersection C. This is our B and C. This is our B intersection C. And now we do the A and B intersection C. So this portion is A. Now we'll first mark A intersection B. The common part with C is this portion. So hence we can write this is equals to A intersection B whole intersection C. This is the law of association, or we can say it is associative law. Now distributive law. In case of distributive law, A union A union B, and then we'll operate with C, getting A union C, and this will be intersection. So A union B, mind that A union is A union. We are writing A union, we are writing also A union. Now there are two sets B and C, so first operate with B and then operate with C. Similarly, for A intersection B union C, A intersection, so we'll write A intersection, then operate with B, operate with C, the bracket, and then union. So we put off union here. The first one is called distribution of union over intersection. Next one is distribution. Intersection. Over union, and later on we prove this by the help of Venn diagram. We'll prove this. But now, identity law. That we are taking a set A, which is a subset of xi. So A union null is equals to A. Simple, because A is equals to, if you take 1 and 2, and xi contains no element. So when you do the union of A and xi, null set, then we'll get obviously just collection of 1 and 2, because there is no element in here. So A union xi is equal to 1 and 2. So equals to A. But A intersection null set is null set because there is no common element between them. A union xi, A union xi, that is union of xi and this, the whole is, because A is a subset of xi, so A union xi is equal to xi, but xi is the universal set. And A intersection universal set is equals to A. Only this portion, the common part of xi and A. So that is equals to A. Complement law. So this is a complement. This is the universal set, the rectangular box is a subset of A is xi inside the xi, A is a subset of xi, and A complement is this region which is the outside of A. Now the laws are A union A complement, that is A and the complement, so that is equals to whole universal set. So we are writing xi here. A intersection A complement, because no common element between A and A complement, so it will be 5 or null set. Complement of complement, this is the complement whose complement is A. So complement of complement is equals to A. Complement of xi, it will be, and complement of null set equals to xi. Now demorgan's law. For two sets A and B, here A union B whole complement. In this picture, A union B represent this area. Now the question is, which area represent A union B whole complement? That means outside of A union B. And this is the common zone of A complement and B complement. So you can write A union B whole complement equals to A complement intersection B complement. So please pay attention here. Here we are writing union, but here it is intersection. Similarly, A intersection B complement. So here A intersection B, it represents this area. So complement of A intersection B is outside of this intersection, that is A, this is A intersection B, and the complement of A intersection B is this one. And this is the portion which represents A complement union B complement. So we are getting two results for demorgan's law for two sets. A union B complement equals to A complement intersection B complement, and A intersection B whole complement equals to A complement union B complement. Now the third law is A intersection B complement equals to A and B complement is this shown, and this we can define right as A minus B. All x belongs to A but not in B. Now De Morgan's law for three sets A, B and C. A minus B union C. So B union C, if I mark B union C, this one, and A minus B union C. So from A, if we subtract this portion, so we get A minus B intersection A minus C. A minus B, this is A, this is B, so A minus B is this portion. Intersection A minus C, this portion. Now A minus B intersection, C goes to A minus B union A minus C. Law 9, absorptive law. Which two absorptive law? That is A intersection A union B, as A union B and A union B is this whole and A is this, so their intersection must be A. Similarly, A union A intersection B, this is our A intersection B, and A union, that is also A. And why this is called absorptive law? Because B is absorbed here. Okay, thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.